All right, this chapter is set up to give you the tools to start to think about reactions and mechanisms. Not only do we want to give you the thermodynamic tools and the ability to look at reaction coordinates, but we also want to give you the mechanistic tools. Because in organic chemistry, you're ultimately going to have to think about mechanisms quite a lot. And so we need to sort that out. So in this question, it's asking you to identify the electrophile and nucleophile in the first step. So what is the electrophile, the thing that loves electrons? Well, it's going to be positively charged. So this one must be the electrophile. And so then where does that electrophile become attached? It becomes attached at the oxygen on the right. So that must be the thing that loves the positive charge, the nucleophile. And so let's label that nucleophile. So that's there. Okay, and then it says to use curved arrows to represent the flow of electrons for every step and describe the type of mechanistic step. So let's do that. What is this first step where the electrons on the oxygen make a bond with the hydrogen ion? This is called a nucleophilic attack. I prefer to use the David Klein system of identifying mechanistic moves and saying that there really are only 4 obvious mechanistic moves: nucleophilic attack, loss of a leaving group, proton transfer, and possibly a carbocation rearrangement. And so for the most part, 95% of reactions can be described in a combination of those 4 mechanistic moves. And so this first move is making a bond from a lone pair of electrons to a hydrogen ion. That's the nucleophile attacking the electrophile. So we'll call that nucleophilic attack. So what happens here in this reaction, in this step? So in structure number 1, that's what happens. What happens in structure number 2? In structure number 2, it looks like I've lost that OH2 group, that water group, and moving from 2 to 3. And so this looks like those electrons must move here. I must lose water. And so this one was loss of a leaving group. Okay, so what happens between 3 and 4? This one's a little bit tougher to sort out. I've got 1, 2 bonds here, 1, 2, 3 bonds there. I have 1, 2 bonds there, but only 1 bond in that location. And it looks like the charge has moved over. So let's take a look what must happen here. If I have a shift of an alkyl group, then what am I doing? It looks like it must be a carbocation rearrangement. Okay, and so I drew this double-headed arrow here to kind of give you a clue before you started to get into the video. This situation is actually resonance, so it's not a mechanistic step in a traditional sense. But I have the electrons from the OH group coming down from the oxygen to make a double bond, and I'm showing that the positive charge can be delocalized into the oxygen. Then what do I need? I can remember it says to add water molecules when necessary. And I had a water molecule that I lost here. So that water molecule must still be floating around. And so what happens in between 4 and 5? It looks like the hydrogen on the protonated carbonyl group is removed. And the water is what must do that. And so this one is a proton transfer. Okay, that's all there is to it.